Every day today we will talk about this question. 508 is most frequency subtree sum. Subtree sum, there is a definition, is a node, all the sum of the nodes values in the tree. For example, this is just the root and with two value. Actually, there will be a 4 for there, add all of them together, and there will 2 and -3, which is the subtree of itself, because there's no left and no right. But if we have, for example, here another one, this will be one of the subtree, and the totally will be one of the subtree together. So this means it's not only the root, only itself at the root. It will be the subtree. All of the nodes, add them together. This is a subtree, right? And all of this should be checked. At the beginning, this is my thought. Actually, I also wanted to track every node subtree, but at the beginning, my code for here is just to track the root part, but it didn't check all of that. So this doesn't work for the first part. First part, it doesn't work. First part before that, it doesn't work. It didn't get all of the subsum, because why we didn't use this is because each of the sub is based on the previous. For example, for this one, if we want to get all the sub, we need to get the lift part sub based on this sum, and we will get this whole of the left part. This is the source and solution for there. So that's why this part directly for the root is not correct. So here we will use one of the function which use to calculate each of the node. As I said, of the node, subnode is based on the previous node. For example, this one based on the subnode. So that's why we need a helper function. In this function, actually, I think it is not so complicated. We need a goes to left sum and check the node left. Why we need to do this is because we want to get the left part of the subnode first, and then calculate the sum of the left part, calculate the right part, and then we calculate the current sum. Yeah, this is why we recursively record itself first and then sum them together. After we recursive left, active right, and then we calculate the sum. For here, actually, we are using this is one of the map. We will use one of map to store. Map can store the key and the value. For the key for here is a sum. For example, we have one of the leaf node, one of the subtree. Sum is 2. We have another here is part. Is this one is also 2, right? We have two sum of them, but we want to get the most of that. For example, we have 2 of the subtree subsum is 2, but one of the subtree subsum is 1. So then we will return 2. We will not return 1, but we will have 2 of them, or we will have one of the 2 and the other have also the sum is true. Then we need to return all of this. So that's why we use the map to store that. And after we get that, we will be -1 in our this default map dict. And after that, we'll return this sum. For here, we will be after that we will get one of the map. What is the map is for example, sum is 2, we have 3, and sum is 3. For example, we have 1. This is our all of these ones. Then we will use this map to check and return all of this with the most frequency. Okay, I think that is all for my thoughts and solutions for this one. For this one, I think I better understand when we can directly to check. when we can directly track, and when we need a helper function. For these solutions, actually, we have two parts we needed to understand. One is the recursive, root recursive. The other one is use the map to store. Map is the most useful of the data structure we should know. Yeah. Thank you. Bye.